Hello, everyone. Hope you're all ready for some fun with arithmetic progressions today. Now, have you ever wondered why your bank balance keeps growing every month or how much money you'll have after a few years of saving? This is exactly where the concept of arithmetic progressions, or ARPs, comes into play. Imagine, every month, you deposit a fixed amount into your bank account. Over time, you see your balance growing by the same amount each time. That's an arithmetic progression. So, let's break it down. An arithmetic progression is simply a sequence where each term increases or decreases by a constant value. This constant is called the common difference. The first term in the sequence is represented by A, and the common difference is represented by D. But here's a question: how do we find out the total amount accumulated in our savings by a certain time? That's exactly what we are going to figure out today. Let's now take a deeper dive and see how this formula is derived, shall we? To understand this, let's look at the sum of an AP from the first term to the last term. We can write this as, now, let's reverse this sequence. It's a little tricky, but trust me, it's fun. We can write the same terms in reverse order. When we add both these expressions together, guess what happens? Each pair of terms adds up to the same thing. The first term and the last term add up to 2a plus n1d. The second and second last terms add up to the same, and so on. So, by dividing both sides by 2, we get the final formula for the sum of the first n terms. There you have it. We've just derived the formula step by step. Isn't it amazing how simply reversing the sequence helps us see the symmetry? Just like organizing your desk to make everything clear. Now that we know the formula, let's see it in action with an example. Suppose on the first birthday, you start saving 100 rupees, and each subsequent birthday, you increase the savings by 50 rupees. So, the second birthday you save 150 rupees, the third one 200 rupees, and so on. How much money will be in the box on the 21st birthday? We use our formula here. The first term is 100 rupees, the common difference is 50 rupees, and the number of terms is 21. Plugging these values into the formula, so, by the time your daughter turns 21, the total money collected in the box will be 12,600 rupees. That's a nice chunk of change. You could have saved 100 rupees every month, but this method of increasing the amount each year just makes the savings grow faster. Let's move on to a slightly more complex example. Say you have an AP where the first term is 24 and the common difference is -3. Now, you know the total sum of the first n terms is 78. Your task is to find out how many terms it will take to reach that sum. We use the formula for the sum. Simplifying this gives us a quadratic equation that we can solve for n. After solving, we get n is equal to 4 or n is equal to 13, which means there are 4 or 13 terms in the sequence that give us a total of 78. Interesting, isn't it? You can see that even with negative numbers, the sum still works out.